This example says to find the coordinates of the point of intersection of the unit circle and a negative 135-degree angle. Now, quick review. This is your starting point on your unit circle. So this point that I just drew is 0 degrees. If you have a positive angle, it's because we rotated counterclockwise. If we have a negative angle, it's because we rotated clockwise. So in this case, we're going to rotate clockwise, or we're going to start rotating down away from 0 degrees until we get to 135 or negative 135. So if I start at 0 and I go down to this first point, that would be negative 90 degrees. If I rotate again to this point, that would be negative 180. So this angle that we're talking about has to be between the negative 90 and negative 180, which is quadrant 3. It doesn't have to be perfect when you draw your line. But this angle that I just drew is negative 135 degrees. So what you're going to do is take this ordered pair that we're trying to find and draw a straight line down to the x-axis. This forms a special right triangle. Okay? You always draw from the point down to the x-axis. Now, you have to do a little math here. I know that this angle is 135, but I also know that a straight line is 180, which means in this triangle that I just drew, I must have a 45-degree angle in here. If this is 90 and this is 45, I must have a 45, 45, 90 special right triangle. Now, the rules for your 45, 45, 90 special right triangle are that this, let me change colors. This side length is just S, which means this side length is also S, and the hypotenuse is S times the square root of 2. Now, if you know anything about the unit circle, hopefully you know that its radius is 1. Now, if I start from the center and I work my way to the point on the circle, I've gone a distance of 1, which means the hypotenuse must be 1. So we know that S square root of 2 is equal to 1. Knowing this, I can solve for S. Which means the side length is equal to 1 over the square root of 2. Now, we're not supposed to leave a radical in the denominator, so with one step, I'm going to multiply the numerator and denominator by the square root of 2. The numerator just equals the square root of 2. The denominator, square root of 2 times square root of 2, is just equal to 2. So our hypotenuse is 1, and each of our side lengths are square root of 2 over 2. Now remember, we're trying to find the ordered pair on the circle. So you can see that it's in quadrant 3 which means we move to the left and we move down to get to that point. I moved to the left along this triangle, a length of square root of 2 over 2. I also moved down the length of this triangle, square root of 2 over 2. If you move left, that's a negative x value. And if you move right, sorry, not right, if you move down, that is also a negative y value. So we move left and we move down. So those are both negative coordinates. So if we take this one step further, the cosine of negative 135 degrees is just the x value of our ordered pair, which is negative square root of 2 over 2. The sine of negative 135 degrees is the y value of our ordered pair, which is the same thing, negative square root of 2 over 2. Tangent is y divided by x, which is the same thing as sine divided by cosine. Well, in that case, we're just dividing negative square root of 2 over 2 by itself. Anything divided by itself is 1. So the tangent of negative 135 degrees is positive 1.